Alright, we're skipping around here a little bit, and we're going to look at 5.7 here, which is graph linear inequalities in two variables, and this is very similar to graphing a line, a linear equation. Okay, here we've got the inequality negative x plus 2y less than 8, and we've got three ordered pairs we want to test out to see if they're solutions. And to do that, we're just going to take their values, plug it into the inequality. If it gives us a true statement, we have a solution. If it gives us a false statement, it's not a solution. So just keep in mind that the first point of the ordered pair is the x. The second point is the y. So I'm just going to go ahead and label those all. And let's plug this in and see what happens. So we take negative times the 0 plus 2 times the 0. And we want to see, is that less than 8? Well, this is 0 plus 0. 0 plus 0 is 0. Is 0 less than 8? Yes, this is true. Therefore, it is a solution. Okay. Now if we try the next one here, we got negative 0 plus 2 times 4 less than 8. Test whether or not this is true. So we got 0 plus 8. Is that less than 8? So 8 less than 8. Is 8 less than 8? No. 8 is equal to 8. So this is false. So this is not a solution. Okay, testing out this last one here. We got negative times the 3 plus 2 times 5. Is that less than 8 is the question. So negative 3 plus 10, is that less than 8? Negative 3 and 10 is 7. Is 7 less than 8? Yes, it is. So here we have a true statement. Therefore, it is a solution. So this right here just kind of summarizes the steps we're going to go through to graph an inequality in two variables. The step one is to graph the boundary line, and we're going to use the techniques that we had to graph a linear equation, like slope-intercept form, y equals mx plus b, a t-chart, picking values for x and plugging it in to find the y value. May even use the intercepts method, where you plug x in for 0 and solve fine for y, and plug 0 in for y and solve for x. So we're going to use a method like that. If you have a greater than or just less than symbol, you're using the dash line. If you have a greater than equal to or a less than or equal to symbol, you are going to use a solid line. After you've done that, then you're going to test a point that's not on the boundary line by checking whether the ordered pair is a solution for the inequality. And then the third thing is just going to be to shade the half plane containing the point if the ordered pair is a solution of the inequality. And if it's not a solution, then you're going to shade the other half. And here in the next two problems, I'm going to walk through these steps so you'll see how that's applied. Alright, here we've got the inequality y is greater than 3x plus 1, and we want to graph it. So I'm going to treat it like it's an equation. So I'm going to write y equals 3x plus 1. And the method I'm going to use to graph this is slope-intercept form. So we got y equals mx plus b. Whatever's in the m location is the slope. Whatever's in the b location is the y-intercept. So I know that slope, which is the m, equals 3. If you write that as a fraction, 3 over 1, which means we are going to rise and run from one point to another. The y-intercept is going to be the b, which is 1. So I'm going to go over here to the y-axis, put a point at 1, then I'm going to use the slope to get the next points from there, and that's up 3 over 1, up 3 over 1, and I'm going to keep doing that. Going back to the y-intercept, I can even go down 3, back 1, down 3, back 1, down 3, back 1. That was the first step. Let's graph it. We've got a greater than symbol. So that means we want to use a dashed line So the dashed line is going to look like this, and I'm going to put an arrow on both ends to show that it continues out infinitely. And next we want to pick a point to test that's not on that boundary line. So like this point here. That's clearly not on the boundary line, and that's coordinates are -4, 0. So I'm going to plug that in and see what happens to the inequality and see if we get a true statement or not. So if we've got y greater than 3x plus 1, I'm going to plug in 0 for the y. I'm going to plug in -4 for the x and go from there. 3 times -4 is -12. -12 plus 1 is -11. So these are all question marks. Is this true? Is 0 greater than -11? Yes, this is true. And what that means is we have a solution. Since we have a solution, we want a shade on the side of the line that we drew, the boundary line, that includes that point, because that point is a solution. So it looks something like this. This means everything that falls in this shaded area is going to satisfy the inequality. Alright, here we've got the last example here, and the inequality to graph, which is 2y less than or equal to 4x minus 10. So again, I'm going to treat it like an equation. So I'm going to write 2y equal to 4x minus 10 just to get our boundary line. And it's easier to work with y's by itself, so I'm going to divide by 2, and if I divide the left side by 2, I divide everything else by 2 just to keep it proportional. So here we got y would equal 2x minus 5. And this one I'm going to use a t-chart. So I'll put this in here. Let's say I use 0 for x, 1 for x, and 2 for x. Get at least 3 points. If I plug 0 in here, I get 2 times 0 plus 5. Or I'm sorry, not plus 5, minus 5. Let me change that real quick. Okay, and 2 times 0 is 0. 0 minus 5 is -5. So when x is 0, y is -5. I'm going to plug a 1 in. And when we do that, we get 2 minus 5, which gives us -3. So when x is 1, y is -3. When I plug a 2 in there, we get 4 minus 5, which gives us -1. Okay. And if we see a pattern here, as x increases by 1, goes up by 1, goes up by 1. So if we went up by 1 again, look at the y, it goes down by 2, down by 2. So we could predict that that would be the next y value would be 1. So I'm going to go ahead and graph those points. We got 0, -5. We've got 1, -3, 2, -1, and 3, 1. Okay, so we've got some points there. Now we have an equal to symbol in our inequality, less than or equal to. So this is going to be a solid line. Okay, now that our boundary line is done, I'm going to pick a point that's not on the boundary line. I'm going to do the origin. That'd be easy to plug in, 0 for x and 0 for y. So when we do that, we've got 2y less than or equal to 4x minus 10. So if I put 0 in for y, 0 in for x, I should label here, this is the origin, 0, 0. We get 0 on the left. We get 0 minus 10 there, and 0, is that less than or equal to -10? No. So what that means is, since that point is not a solution, we can't include it, we can't shade that way. So we're going to shade the other half of the inequality, and it looks something like this.